Hello, and welcome to the Python for Data Science Comprehensive Journey to Mastery course. My name is Mustafa. I am very happy to have you here, and I really wish you an interesting journey with me. At the beginning, we should ask a very important question. Why we use Python for data science? Python is one of the most popular programming language for data science for multiple reasons. Firstly, it's ease of learning and use. It has a very simple syntax with large community and resources. Secondly, here its extensive libraries and frameworks, like as we will see during this course, pandas, numpy, matplotlib, scikit-learn for building machine learning models. Thirdly, its integration with other tools and languages. Python here provides seamless integration uh, with other programming languages and tools. You can easily incorporate SQL for database queries, use Python in Jupyter notebooks for interactive data analysis, or even integrate Python with Hadoop for big data processing. Also, Python provides seamless integration with APIs and data sources. It can easily connect with various data sources, such as databases, web APIs, and the cloud services, which allows us to access and work with a wide range of data. Python here provides a a support for machine learning and AI. With Python, you can work with famous frameworks like TensorFlow, Keras, and PyTorch. The fifth reason here, which is very important, is using Python with data visualization and reporting. It can provide interactive plots with a very insightful dashboards, especially for non-expert stakeholders. The sixth reason here is Python's scalability and performance, which enables it to work with large datasets with high efficiency. The seventh reason here is the community and the ecosystem of Python. It provides a vibrant community. Also, Python and most of its data science libraries are open source, which means they are free to use and are continuously improved by contributors from around the world. Lastly, and maybe the most important reason, is are the career opportunities is the career opportunities you can get from mastering Python. Python is the industry standard for data science, and proficiency in Python is often a requirement for data science roles. Learning Python opens up numerous job opportunities and career paths in data science. In data science, also in machine learning, AI, and data analytics. Some important things to take care of while working with Python is that Python is case sensitive programming language, and spacing identification in Python is important. Case sensitivity here means that uppercase and lowercase letters are treated as distinct. For example, the variables name, and name, with here in capital, in small, and all characters capital, are all different. This applies to all identifiers in Python, such as variable names, function names, and class names. Some examples here that shows the case sensitivity. Yes, let's say here we name Alice and name Bob with N capital. The output here is Alice is different. Yes. Let's add another example. We have a name Mustafa. Name here is N capital. And we try to print name but with N small. We will have here a name error. Name error because name is not defined. In Python here, indentation also is crucial because it defines the block of code, the blocks of code. Yeah. Unlike other programming languages that use braces to define blocks of code. For example, here loops, functions, and conditions, as we will see in the future lessons. Python here uses indentation to group statements together in one block of code. Example here of proper indentation. Uh, let's say here we are writing an if condition, if true, for example, and colon print. This is indented correctly. This print here is part of the if block, but the second print here is not part of the if block. Yes, we know that by this indentation. Let's add another example of incorrect indentation. If true colon and there is no spacing here, we get an indentation error. Expected an indentation block. Why is this important? This is important for multiple reasons. Firstly, readability. Python's use of indentation helps make the code more readable. Secondly, the syntax errors. Incorrect indentation or inconsistent use of case sensitivities can lead to syntax errors that prevent our codes from running. This is the introduction for our course. I really wish you an interesting journey with us during learning this course, and see you next lessons. Hello. In this lesson, we are going to talk about data types, operators, and data structures in Python. Uh, let's firstly start by talking about data types. Data types in Python defines the type of data that a variable can hold and how that data can be processed using various Python instructions. In Python here, there are several built-in data types, and understanding them is crucial for writing effective code. In this lesson, we will encounter mainly four different data types. Firstly, we will talk about integers. Uh, Integers in Python represent whole numbers without additional points. It can be negative, it can be positive. Yes. For example, it can be 41, it can be 44, and minus 1. The second data type we are going to talk about is floats. Float in Python represents three numbers with a decimal point. For example, it can be 3.14. The third data type we are going to talk about is Boolean data type. Boolean represents two possible values, true or false. And lastly, we will talk about string data type. String data type represents sequences of characters. Uh, for example, here It can be a word, it can be a phrase like hello, how are you? It can be a document or an article. We use strings data type to be able to process string and process text data. Uh, it it's mainly used in natural language processing applications. Uh, when we define strings, we can define it using single quotes and double quotes, as we see. We will further see in this lesson. Yes. Now let's talk about operators in Python. Operators in Python are special symbols or keywords. Uh, those symbols and keywords uh, that ca- we can use to perform operations on operands. Operands here are variables or values. They are used to manipulate data and perform various types of operations, such as, for example, arithmetic calculations, comparisons, and logical operations. Python has several categories of operators, each serving a different purpose. In this lesson, we will talk about four different types of operators, and the rest of operators we will talk about in next lessons. Let's now start by talking about arithmetic operators. Arithmetic operators in Python are used to simply perform mathematical operations. It can be addition, subtraction, multiplication, division, modulus, exponentiation. Uh, Addition here, let's start talking about each operator. Addition here, for example, you can use to add two operands. For example, I can here add 3 plus 4, and the result is will be 7. We can use subtraction operator to subtract the right operand from the left operand. We can use multiplication operator to multiply two operands. That is 3 times 8, 24. Can use division operator that divides the left operand by the right operand. 15 over 5 plus 3. We can use modulus operator to return the remainder of division of left operand by the right operand. For example, here 16 modulus 5 equal 1, and 15 modulus 5 equals 0, because there is no remainder by doing this operation. We can also use exponentiation operator like this to calculate 3 to the power 3 equal to 27. Exponentiation here raises the left operand to the power of the right operand. The last operator here in arithmetic operators is floor division. You can use floor division, yes, like this. Now let's talk about assignment operators. These operators are used to simply assign values to variables. Variables on in Python can hold any type of the different data types that we talked about. It can hold integers, it can hold floats, it can hold boolean, it can hold strings. For example, here I can use the assignment operator to write to define x equal 5, and then the equal here assigns the right operand to the left operand. I can also use another assignment operator, which is addition and assign. By using this, yes, like this example, by using this, I can add the right operand to the left operand and assign the result to the left operand. This is simply equivalent to x equal x plus t. Yes. The first one is 8 and the second one, after adding 3, another 3, equal 11. We can also use subtract and assign, multiplication and assign, divide and assign, modulus and assign, and all other operations or other arithmetic operations with assign to do the same thing. Yes. If I wrote here x minus equal 3, it will be 8 equal 4. The result will be 2. No, it's not 2. Because I divide 2 times, the result will be half. If I wrote here x times equal 4, the result will be 2. But here, as you can notice, 2 here is a floating point number because I previously used the division, and the result of the division of dividing two integers is a floating point number. X exponentiation with a sign. The result here will be 8. To be able to check the type of the variable, we can simply use type function to know the exact type of x. Yes, for example, x here is floating point number, and firstly it was an integer number, but after we did multiple operations, the type of x changed to floating point number. To return it back to an integer number, we can simply cast x to be an integer number using this. When we print type of x, we will find that the type of x changed from float to integer. Let's now talk about comparison or relational operators. These operators compare two operands with each other and returns a Boolean value, whether it is true or false. There are different types of comparison operators. For example, equal equal, which checks if two operands are equal. For example, here I can check if 3 equal 3. Yes, the result, of course, will be true. I can check if x equal 3. The result will be false. X equal 8, it's true. I can also use uh, not equal operator, not equal 3. The result is true. Not equal here checks if two operands are not equal. Yes. We can also use greater than, less than, and greater than or equal, less than or equal operators. I can here check if x uh, is greater than 5. The result is true. Greater than obviously checks if the left operand is greater than the right operand. And less than checks if left operand is less than the right operand. Yes, for example here, I can check if x less than 5, the result is false. We have also greater than or equal to, which checks if the left operand is greater than or equal to the right operand. And less than or equal to checks if the left operand is less than or equal to the right operand. If I try to check if x greater than or equal to 8 or 5, the result will be true. The result here is false. The result here is true. Let's now talk again about strings, but with more details. As we said before, we can define strings using single quotes or double quotes. For example, I can define string equal hello and string 2 equal world. Yes, I can concatenate two strings or any number of strings using the plus operator. For example, I can here concatenate s1 and s2, and the result here will be hello world. Yes. If I want to concatenate a space between them, I can simply write yes string of space. But what if I want to include a single quote or double quote in my string? I can simply write single quote, write backslash before single quote or double quote to be able to include it in our in my string. Yes. For example, here I can print yes. If I remove the backslash, I will simply get an error. Yes. So the backslash here is important to be able to include these characters inside my string. Yes. I can also do this using strings. If I wrote, for example, s uh, times 4, I find that s concatenated uh, four times. Uh, yes, using strings, I can access different characters inside the strings using indexing. For example, here I can access the first character uh, from by writing s of 0. The indexing here in strings is 0 indexing, which means I can start indexing from 0 till the length of character of the string minus 1. I can simply get the length of the string using function length. Here length of s is equal to 5. So here, if I want to get the last element in the string, I can simply write s of 4, and I can get the O character. Yes. If I wanted to access also, yes, the last element in the string, I can write reverse indexing. I can write s of minus 1, and I will get uh, O2. Yes. Python supports reverse indexing, but in many other languages it don't support this. Uh, if I tried also here to write s of 5, I will get an error. Yes. Index string index out of range error. Yes. So I should know the length of the string, and according to this I use my index. I can also use string slicing to print or select a specific part of the string. For example, here, if I wrote, if I wanted to get a slice of a string from index 1 to index 4, but 4 here is not included with us. 1, 2, and 3 are included. For the end of this slice is not included with us. So here, the result will be letters ELL. Uh, we should mention also that if I want, when I do concatenation in strings, I I should uh, concatenate two similar types. I should concatenate string with string. If I tried, for example, to concatenate an integer or float two strings, I will get an error. To be able to do this, I should firstly cast the integer and the float to string to be able to concatenate those types with string. For example, here, if I have variable x equal 5 and I want to, I will find an error. Yes, because, but if I casted x to string before doing the concatenation, I will not get an error and I will find that 5 is concatenated with hello string. Yes. Now let's talk about another important part in this lesson, which is string methods. String methods in Python are built-in functions that allow us to manipulate and analyze strings. These methods can perform various operations, such as modifying, searching, or formatting strings. In this lesson, we will take an overview of some of the most commonly used string methods, and I will include attached to this lesson a file contains all string methods to be able to play after this lesson with them. Let's start by talking about string capitalize method. Uh, String capitalize here capitalizes the first character of the string and converts the rest of the string to lowercase characters. For example, here if I have a string s equal hello world using s dot capitalize. This is the result. As we see here, W in world is small, and the only character, the only capital character is H in hello. Another important method here is string lower. String lower simply converts all characters in the string to lowercase. For example, here we can write s dot lower And I can notice that all characters in the string now are small case. I can also use string.upper to convert all characters in the string to uppercase. Yes, like this. Another important method also is string.title. String.title here capitalizes the first letter of each word in the string. So here our hello world will become hello world with H and W capitalized. An important method here, especially in natural language processing, is string.strip. String.strip here removes any leading or trailing white spaces. Uh, White spaces or specified or any specified character from our string. For example, here, if I had s equal hello world, when I print s at the beginning, at the first time, can find that I can find that the first string is printed with white space characters in the left and in the right. And after using strip method, the method removed the white space in the left and in the right. Yes, I can also use L strip and right and R strip. L here stands for left strip and there are right strip. Yes. To remove leading white space, uh, we use left strip. To remove trailing white space, we use R strip. Yes. Yes, if I did this, for example, I can do this, for example, s dot L strip and s dot R strip. As I can see here, L strip removes the leading white spaces and R strip removes the trailing white space. Another important method uh, method string is find method. Find method here returns the lowest index in the string where the specified substring is found. So here, if I want to search uh, for a specified string inside a string, it the find string here returns the lowest index in the string where the specified substring is found. Yes. If it didn't find this substring, uh, this the substring of course starts from just one character to any length that we want to look for. If I didn't find this substring, the function here just returns -1. So here, for example, if I wrote is equal hello world, find of find world. If I wanted to search for just one character like O, I can simply here the O here returned the index of the first O, which is 4, and the world and returned the index of the start index of the first world inside our string, which is index 6. Another important method is string.replace. String.replace here replaces all occurrences of the specified old substring with the new substring. Uh, so here, for example, if we have here our hello world string. When I try to print s dot replace the old substring, here let's say it's the world with the new substring, which is for example can be Python, hello Python. We will find the result is hello Python. So here Python replaced world, yes, in our string. Another important method here is split method. Split method here splits our string into a list of substrings. This is done based on the specified operator. Uh, if no operator is specified, it splits defaultly by white space. For example, here our string hello world, I can print s.split. I will find that it will return will return a sequence of two strings with hello, uh, with two strings hello and world. Yes. If I wrote here, for example, we have two equal hello world Python, and I wanted to split using this card. Yes, not using the white space. White space is the default value of the splitting operator. But here I can specify any characters that I wanted to use uh, to split the strings inside the string. So if I wrote this, I simply will get a sequence of three elements: uh, hello, world, and Python. Another important method here is string join. String join here uh, joins the elements of an iterable. For example, a list iterable here can be a list, can be a table. We will talk in more detail about iterables and the data structures in later on in this lesson. Yes, but for now we can say that iterable can be data structures that I can iterate over their elements. It can be a list, it can be another data structure called a tuple, it can be a set, it can be uh, any sequence that I can iterate over its elements. So here I can use join with any list to join their elements into a single string with the original string uh, as a separate. For example, here with the original string as a separate. For example, here if I have a sequence of or a list of strings, I can define a list here using this square brackets. We have two elements inside our string. For example, hello Python. Yes. I can join this, yes, as you said before, uh, with the original string here is this white space. I can use this white space as a separator between the elements of the sequence. Yes. The result here will be world Python. Yes. Uh, the original string used as a separator between world word and Python word. If I put another word in our sequence, hello, I will find that the string here contains three words: world, Python, hello. Yes. Another important methods here are starts with string method and ends with method. Yes. Starts with it checks if the string starts with a specified prefix and ends with checks if our string ends with a specified suffix. The return value from those two methods are true or false. It just tells me if the string starts with a prefix or if not, or if the other method starts with uh, ends with a specified suffix. For example, here, if I wrote, I can find here that there is an error here. Yes, S is a list, not a string. Yes, and simply redefine S. The result of the two methods are true and true. Yes, are true and true because this string starts with hello and ends with world. Another important method is digit. Method is digit here returns true if all characters in the string are digits, and there is at least one character. Otherwise, it returns false. For example, here, if I have a string num equal, for example, if I check num dot is digit, I can find it is true. If I put here a character if, the result will be false. We have also another method called isAlpha. IsAlpha here returns true if all characters in the string are alphabetic, and there is at least one character. Otherwise, it returns false. For example, here we can have can check here if s lot is it is false because s includes a space or a space. Yes. If I modify s, the result will be true. We have also string dot is alnum. Alnum here stands for alpha numeric. This method returns true if all characters in the string are alphanumeric. which means they are either letters or digits, and there is at least one character inside the string. Otherwise, it returns false. For example, here, if I have s equal hello world 123, the result will be 2. Yes. Another important method here is the count method. Count here returns the number of occurrences of the specified substring in the string. For example, here, if I want to count the O character of the last string here, hello world not 3, I can do this. Print count. I will simply, yes, get 2. Another important method here is string partition. String partition here splits our string uh, into 3 parts. The first part uh, and a separator, and the last part. The separator here, which I specify when I define or when I call the function, the method. The main job of the separator is to separate our original string into 2 parts. The part before the partition is the separator, and the part after the separator. The main uh, the main function of this method is to return the part before the separator and the separator and the part after the separator. If I didn't find uh, the separator inside the string, I can simply the method here simply returns the original string and 2 white spaces, 2 empty strings. Yes. For example, here I can define s equal hello world again. If I call partition white space, I can simply get hello and the white space and word. If I tried to, for example, put a instead white space is not included. Here the method simply returns hello world and 2 empty strings. Those are the methods that we will talk about in this lesson. I will include more lessons in the attached file, as I told you. Uh, I should mention here that these string methods allow us or allow powerful and flexible manipulation of text data in Python. Whether you need to modify, for example, search or format strings, these methods are essential tools for working with text data in Python, especially in natural language processing applications. Let's start now talking about data structures. Uh, During this lesson, we will talk about different types of data structures, like, for example, lists, tuples, sets, dictionaries, and compound data structures. We will also talk about two new operators, membership operator and identity operators. Uh, let's start here by defining data structures. Data structures are containers or collections that can organize and group data types together in various ways. They are essential for optimal data management, efficient data processing, logical data structuring, and effective data storage and retrieval. Yes. We can use data structures also to handle various data operations. The first data structure that we will talk about uh, is lists. A list here is an ordered collection of elements. You can create a list using square brackets, as we'll see. S here can be those numbers. Uh, a list can contain a mix of different data types, and list indexed starting from zero, the same as strings, as we said before. Uh, and you can access elements using their indices. Uh, this is also support slicing, which allows us to extract a subset of elements from the list, like we did before using strings. Lists also are mutable, which means you can modify their elements after creating them. Yes. Other data structures are immutable, which means we cannot modify them after creation. Yes. For example, here if this list contains five numbers, 1, 2, 3, 4, 5, can create another list, contain different data types. For example, 1 represents integer 3.14 as a string, and hello as string, and true as boolean. Yes. When we print L, yes, we simply print all elements of the string, uh, and all elements are with different types. Yes. As we said here, uh, list is indexed starting from zero. I can get the first element by writing L0, and I can print last element by using, for example, length of L minus 1, as we said before. And as we said before, we use zero indexing in order to access list elements. And for that last element here is the length of the list minus 1. Yes. I can also get last element using print of -1 as L of -1. As we said before, Python supports reverse indexing, as we said before, using strings. We can do the same also using lists. So here I can get the last element using these two ways. Lists also support slicing, as we said, which allows us to extract a subset of elements from the lists. So here I can print a slice of L includes the second and third element by writing this. No, it's not the second. Yeah, it's the second, the third, and fourth element. Because here the length of the list is four. Yes. If I wrote it to three, I will get the elements with index one and two. Yes. If I want to get the first three elements, I I don't need to specify the starting index of the slice. So here I can simply write this, and I will get the first three elements of the list. I can also, if I want to get to the last elements of the list, I can not specify the end of the slice, and I will get the last three elements of the list. We mentioned also that lists are mutable, which means we can modify them after creation. Yes. For example, here I can simply write L of 0 equal 1, one string instead of 1. Yes. And after this, when I print L, I simply find that the list is modified and the one number replaced with one string. Yes. In lists, there are two important methods: the append method and the remove method. Append method here used to append a new element at the end of the list. So here, if I want to append, if I want to append name, for example, to my list, I will find that name string is appended into our list. I can also remove any element that I wanted to remove from the list using l.remove. If I remove name, I will find the list now without the string name. Now let's talk about another interesting data structure, which is a tuple. A tuple is an ordered collection of elements. It's similar to lists, but it's immutable, which means we cannot modify it after creation. Tuples are often used to store related pieces of information. For example, here, uh, let's say we want to create a location tuple. This location tuple contains two numbers, the latitude and longitude of a location. To create a tuple, we use parentheses like this. After printing this, the values of this tuple are the latitude and longitude of this location. To create a tuple, also we can create it without parentheses. Parentheses here are optional. So here we can create another tuple, contains the different dimensions, length, width, and height. Can contain, for example, 12, 24, and 36. Uh, and in tuples also there is a very interesting feature, which is unpacking, used to unpack the values of the tuple that we are working with. So here, if I want to get the original elements of the tuple, I can simply write length, width, and height equal dimensions. After printing these dimensions, we can simply get the original elements of this tuple. We mentioned before that tuples are mutable, which means we can not modify its elements after creation. So here, if I try to do this, dimensions of 0 equal 10, I will get an error. Yes. But what if I want to modify any element of this tuple after creating it? I can simply do this, but by changing the wall tuple. So here, for example, I can update the wall tuple with its new elements like this. The first element is modified, and second and third elements are the same. So here, yes, the new tuple is this is the new tuple. Let's now talk about another interesting data structure, which is set. A set is an unordered collection of unique elements. Sets are useful for quickly removing duplicates from a list or performing mathematical set operations like union, intersection, and difference. Let's have an example here. Uh, Imagine we have a list that contains those duplicate numbers. When we create a set of these lists, we will find that these sets only get the unique elements of this list. So here it contains only 1, 2, 3, 4 instead of all those elements. We can create sets using the keyword set, or we can create it using curly brackets. As we see here in the second example, uh, if we created a set called fruits, contains different types of fruits. This set contains apple, banana, and oranges. So here, if I try to check if a fruit is included into this set or not, I can use this operator. This operator is called membership operator. Membership operators checks if an element is included into an iterable data structure. Uh, so here I can use this in operator with sets. I can use it with lists, with tuples, with dictionaries, as we see. Uh, Here I'm using it to check if watermelon is included into fruits or not. And obviously it's not included into fruit set. Yes. To add watermelon into our set, we use the add method. Dot add method. Dot add method here includes a new element. Add a new element to our set. But here the added element is added randomly into our set. So here, not like the append method in list as we talked before. Append method appends any new element at the end of this list. But here the add method added the new element, adds the new element to randomly to the set. Yes. So here after printing fruits, we will find that watermelon is added at the end of this set. Yes. Let's add another element, which is, for example, mango. And yes, we will see here that mango is included, is added at the beginning of this set. To be able to remove an element from our set, we simply use dot pop element. Dot pop element, like add element, removes an element randomly from the set. So here, when I write dot pop, I will remove a random element from my set. Yes, the random element here removed here is orange. So after printing fruits, I can see that fruits set don't include orange element. Yes. Now let's talk about another interesting feature of sets. Uh, let's create two sets. Vowels set that contains vowels characters, and set called word contain uh, any word that we want to work with. Let's say hello. After creating those sets, let's try to find the intersection between those two sets by writing vowels dot intersection of word to see the intersected characters between set vowels and the word hello. Yes. Let's also print the union between those two sets and the difference between those two sets. After printing those, yes, you can find here. Yes, this is the first set, and this is the second set. This is the intersection between the two sets. They are intersected with the O and E characters. This is the union between them, and this is the difference between them. Let's now talk about dictionaries in Python. A dictionary in Python is a mutable data type that stores mappings of unique keys to values. Keys here must be immutable types, like strings, integers, or types. Let's have an example here. Let's create a elements dictionary. The elements dictionary here contains some elements from periodic table and maps those elements to their atomic number. So here, for example, we are having a dictionary of helium, carbon, and hydrogen, each map to its atomic number. When we try here to check if the specific element is included in the elements dictionary, we are using the membership operator in. Membership operator in is used to check the membership of any element in any iterable. Any iterable here can be lists, can be tables, can be dictionaries, can be sets. I can simply check the membership of any element using the in operator. Carbon here is included in elements dictionary, so the output here will be true. If, on the other hand, I tried to check the existence of dilithium in elements dictionary, I will get false because dilithium is not included in elements dictionary. If I want also to get the value of a specific element inside the dictionary, I can use the .get method. .get method, for example, here ls.get dilithium, as dilithium is not included into our dictionary, this will return none. To be able to add a new element to our dictionary, we simply we just simply include this element into the dictionary uh, by this line. Elements of dilithium equal its atomic. By just writing this, I add this new element to my dictionary. As we see here, dilithium dilithium is now included into our dictionary. But what if I wanted to delete a specific element from uh, my dictionary? I can do this by simply using the del keyword. By using the del keyword, I can delete any element I wanted to delete. Here I use del elements helium to remove the helium elements from the dictionary elements. After this, I can find that helium element is removed from my dictionary. To be able to iterate over the elements of any dictionary, I can use the dot items method uh, in dictionary here and for loop. Yes, uh, we will take we will talk about for loops in detail next lesson. But for now, we just wanted to know that for loop is used to iterate over any iterable uh, and get each element from these iterations. I can use for loop with dictionaries, with lists, with sets, tables, with any item. Here I use the elements to items to get the key and value of each element. After this, I can simply print each element, key value of each element. Here I don't forget to cast the value to str to be able to concatenate with this string. We should also mention that we can create dictionaries with mixed keys. For example, here I can map string to integer and integer to string in the same dictionary. For example, here I can map Mustafa to one and to one to Mustafa, and things will be okay. But as we said before, the dictionary, the key should be immutable, can be mutable type, yes, can be strings, can be tuples, for example. As you said before, dictionaries uh, are mutable types, which means we can update after creation. So here, Mustafa info Mustafa equal to will be modified, and this is the yes to get the elements of the values of the dictionary. You can simply put info one and info Mustafa, and we get Mustafa. And now let's talk about an important operator, which is identity operator. Identity operator is using identity operator, we can uh, evaluate if both sides have the same identity. For example, refer to the same object in memory. We can do this using the is operator. Let's have an example here. Uh, we have three lists here. The first list is A, includes 1 to 3 numbers. The second list is B, B equal to A, and the third list is C, C equals to 1 to 3 numbers. Let's now print those four prints. The first print wants to check if A equal B. Second print wants to check if A is B, and the third print checks if A equal C. The fourth print is it checks if A is C. The first output here will be true because simply A and B contains the same values. The second print also is true because A and B have the same identity and they refer to the same object memory because when we created B, we make equal to A, and A equal C is also true because they contain the same values. And but here A is C equal false because they have different identities as they refer to different objects in memory. Let's now talk about another interesting part of this lesson, which is compound data structures. Uh, With compound data structures, we can include containers within other containers to create compound data structures. For example, here we can create nested dictionaries. The elements dictionaries that we created before can hold more information by making it with nested dictionaries like this. I can here, for example, create it firstly with only two elements, hydrogen and helium, and map the hydrogen element to more information of it. Uh, that is a dictionary contains the number, the atomic number, hydrogen, the weight, and the symbol and its symbol. Yes, same here as helium. And to be able to access any element from this nested dictionary, we simply write elements of hydrogen and of weights to get the weight and of weight to get the weight of the hydrogen. So here, by using this, I can get this number. But what if I want to add new element to my elements dictionary? Like we did before with dictionary, simple dictionary, we can create a new element. Let's say it's oxygen, and include uh, oxygen here is a dictionary that includes numbers, atomic number of oxygen, its weight, and its symbol. And to add this element to the elements dictionary, we simply uh, write elements of oxygen equal to oxygen dictionary. And by doing this, we simply can find oxygen included into our dictionary. We can also create other compound data structures. For example, here we can create a list of dictionaries, can create list of tuples, list of sets, and so on, according to our needs and according to what we want to do and our usage. For example, here we had students. Each student's list, each student contain information about each record in the list contains information about the student. Uh, this information is the name of the student, the age of the student, and his or her grades. For example, here we have three students in our list. The first of with name Alice, her age is 20, and both are her grades. Yes, and so on. But what if I want to access elements in this compound uh, network? I simply here access the first index using the way we used to access the list. Here, zero indexing. If I want here, for example, to get the name of the second student, I can write ln students one and the name of the student to get the name of the second student, which is Bob. Also, if I wanted to get the second grade of the third student, I can simply write it this way: the index of the third student and the grades in the dictionary, its dictionary, and the second element of grades, which is the rest. Uh, this represents the grade of the second subject that Charlie got, and here it's you can get it from it's 75. This is the end of this lesson. I hope you enjoyed it, and I hope that you are enjoying the course so far. And see you next lesson.